Hello everyone, I am Sarayu. Today I am here to discuss a course on electrical power generation. Before getting into the course, let's take a pre-test. Hello Nitin, you seem to be tensed. What happened?
Hey, I have been searching for you.
Well, what's the problem?
I have a seminar at my school which I need to deliver it by next week. I have not prepared anything for my topic. So I was thinking to ask you that could you help me out?
Absolutely sure. After all, you are my dearest brother. First, tell me what is the topic?
I've selected a topic on power generation. Help me with the basics of it.
Sure, I will explain you everything about basic of power generation. Did you ever think how these fans, TVs, lights and charging a mobile work?
When I was a kid, I used to think there was some magic happening as we switched them on.
It's not a magic, it is power. This phenomena that takes place when we switch on something actually happens in three stages. They are generation, transmission and distribution. Firstly, I will explain to you about generation.
That is perfect.
Let us look at the objectives. By the end of this course, you will be able to define electrical power generation, illustrate how your home gets electric power, list various sources of energy for power plants, compare various sources of energy. Before getting into the details of any subject, one should have a basic knowledge about that subject. So, let's start with what is electrical power generation. Electricity generation is the process of generating electric power from sources of primary energy. It is the first stage in the delivery of electricity to end users. The other stages being transmission, distribution, energy storage and recovery using pumped storage method. Electricity is not a primary energy freely present in nature in remarkable amounts, and it must be produced. Production is carried out in power stations, also called power plants. Electricity is generated at a power plant by electromechanical generators driven by other sources of energy such as hydroenergy or thermal energy. Did you understand what is electrical power generation?
That was a good start.
Well, sounds good. Now that you have understood about electrical power generation, let's see how this power comes to our house. Electric power generation starts with a source of fuel that can be harnessed to create energy using a generator. Electric current from the generator goes to a transformer, which steps up the voltage of power being transmitted to 132 kilowatt or more before sending to the power grid. From the power plant, the electric current travels through high voltage transmission lines to an interconnected network of substations called the grid. At each substation, transformers decrease the electric current voltage to levels that can be used by factories, shopping malls, houses, and other customers.
One thing I didn't understand is that where does this power come from?
I think you are too excited. That is the next topic which we are going to discuss.
Okay.
Now let us represent various sources of energy in a pie chart. Firstly, let's look at this chart that depicts sources across world in the year 2017. As you can see, they are fossil fuels, coal, oil and natural gas, renewable sources, hydroenergy, wind energy, geothermal energy, solar energy, tidal energy, wave energy, biomass energy, nuclear energy. Similarly, have a look at the chart that depicts sources across India in the year 2018. In a thermal power plant, fuel such as coal, oil or gas is burned in a furnace to produce heat energy. This heat is used to change water into steam in the boiler. This drives the generator to produce electricity in power plant. Hydropower plants capture the potential energy of water and convert it into kinetic energy, which in turn is converted to electricity. A turbine converts the kinetic energy of falling water into mechanical energy. Then a generator converts the mechanical energy of the turbine into electrical energy. A nuclear power plant is like a thermal power plant in which the heat source is nuclear reaction. Nuclear reaction generates heat, which is used to generate steam that drives a steam turbine connected to a generator that produces electricity. There are 450 nuclear power reactors in operation all over the world. Geothermal power plants use steam produced from reservoirs of hot water, found a few miles or more below the Earth's surface to produce electricity. The steam rotates a turbine that activates a generator which produces electricity. There are three types of geothermal power plants: dry steam, flash steam, and binary cycle. Tidal energy is produced through the use of tidal energy generators. These large underwater turbines are placed in areas with high tidal movements and are designed to capture the kinetic motion of the ebbing and surging of the ocean tides in order to produce electricity. Large wind turbines consisting of propellers convert wind energy to electrical energy. As the wind passes the turbines, it moves the blades which spins the shaft. The turbine is connected to a generator to generate electricity. A solar power plant is based on the conversion of sunlight into electricity directly using photovoltaics (PV). Concentrated solar power systems use lenses, mirrors and tracking systems to focus a large area of sunlight into a small beam. It can be stored in a battery or to heat water for a thermal power plant. Wave energy is used to generate electricity using generators which harness energy from the surface of the ocean. The energy provided is most often used in desalination plants, power plants and water pumps. Energy output is determined by wave height, wave speed, wavelength and water density. Biomass can be converted into electric power through several methods. The most common is direct combustion of biomass materials such as agricultural waste or woody materials. Other options include gasification, pyrolysis, and anaerobic digestion. Gasification produces a synthesis gas with usable energy content by heating the biomass with less oxygen than needed for complete combustion. Fuel is stored in a bunker for further transport to the boiler. In the boiler, water is heated to high temperature under pressure. The steam temperature can reach up to 550 degrees centigrade. Steam from the boiler passes the turbine, which is connected to the generator. It's not that every type of source is completely advantageous or completely disadvantageous. They have both pros and cons, which we will look into next.
Cool. Let's get started.
These are the pros and cons of solar energy. These are the pros and cons of wind energy. These are the pros and cons of solar energy. Non-polluting, most abundant energy source available. Systems last 15 to 30 years. High initial investment, dependent on sunny weather. Supplemental energy may be needed in low sunlight areas. Requires large physical space for PV cell panels. Limited availability of polysilicon for panels. These are the pros and cons of wind energy. No emissions, affordable, little disruption of ecosystems, relatively high output. Output is proportional to wind speed, not feasible for all geographic locations. High initial investment and ongoing maintenance costs, extensive land use. These are the pros and cons of hydroelectric energy. These are the pros and cons of wind energy. No emissions, affordable, little disruption of ecosystems, relatively high output. Output is proportional to wind speed, not feasible for all geographic locations. High initial investment and ongoing maintenance costs, extensive land use. These are the pros and cons of hydroelectric energy. Natural gas. These are the pros and cons of natural gas. Widely available, cleanest burning fossil fuel, can be combined with other fuels to decrease pollution, made safe by adding artificial odor to detect the gas in case of a leak. Transportation costs are high. Lack of infrastructure makes gas resources unavailable from some areas. Burns cleanly but still has emissions. Pipelines impact ecosystems. These are the pros and cons of petroleum. Efficient transportation fuel for the world. Basis of many products, from prescription drugs to plastics. Economical to produce, easy to transport. High carbon dioxide emission, found in limited areas. Supply may be exhausted before natural gas or coal resources. Possible environmental impact from drilling and transporting. Here are the pros and cons of biofuel. Abundant supply, fewer emissions than fossil fuel sources. Can be used in diesel engines. Auto engines easily convert to run on biomass fuel. Source must be near usage to cut transportation costs, creates pollution emission of gas or liquid waste, increases emissions of nitrogen oxides and air pollutant, uses some fossil fuels in conversion. Let us now see the pros and cons of nuclear energy. No greenhouse gases or carbon dioxide emissions. Efficient at transforming energy into electricity. Uranium reserves are abundant. Refueled yearly, unlike coal plants that need train loads of coal every day. Higher capital costs due to safety, emergency, containment, radioactive waste and storage systems. Problem of long-term storage of radioactive waste. Heated wastewater from nuclear plants harms aquatic life. Potential nuclear proliferation issue. These are the pros and cons of coal. Abundant supply, currently inexpensive to extract, reliable and capable of generating large amounts of power. Emits major greenhouse gases, acid rain, high environmental impact from mining and burning, although cleaner coal burning technology is being developed. Mining of coal is a hazardous activity. These are the pros and cons of geothermal. Minimal environmental impact. Efficient. Power plants have low emissions, low cost after the initial investment. Geothermal fields found in few areas around the world. Expensive startup costs. Wells could eventually be depleted. These are the pros and cons of tidal and wave energy. No emissions, reliable, capable of generating large amounts of power. Output is erratic. Environmental impacts caused due to restriction of ocean currents, Tidal dams are expensive to build. So, this is all about the power and its generation, and it is not any magic as you thought.
Yeah, thank you so much. That was clear.
All the best for your seminar.
Thanks, sis.
We have come to the end of the first module of electrical power generation. Here is a quick recap of the key points discussed in this module. In this module, we have learned that electricity generation is the process of generating electric power from sources of primary energy. The various sources of energy are fossil fuels, coal, oil and natural gas, renewable sources,
hydroenergy, wind
energy, geothermal energy, solar energy, tidal energy, wave energy, biomass energy, nuclear energy. Each type of energy source has its pros and cons. Thank you for your time. Hope you enjoyed learning. Click next to take the first test.